Okay, so moving on to our last question here. This is again a really common question. I want you to think about this one for communication and thinking, right? Because like I was saying, there's not a lot of ways of sort of doing it in this unit. It's asking us for an algebraic expression for the area of the shaded region. Now, of course, the area of the shaded region, right, the way you want to think about this, the area shaded is equal to the area of the big rectangle minus the area of the small rectangle. And that type of thinking is really important. You're going to need to do that. So make sure, like when you look at a shaded picture, you're always thinking, okay, is there a big shape that I can, or is there a small shape I could subtract from a big shape in order to get what I need here? So the area of the big rectangle, right, which actually when we look at it is a square, the area of the big rectangle equals x plus 9, that would be its length, and then another x plus 9, that would be its width, right? The area of the small rectangle is equal to x minus 3 times x plus 3, right? So that would be the 2. Now the area of the shaded region would be x plus 9 times another x plus 9 minus x minus 3 x plus 3. Now this is true, but it's not really written in a form that's particularly useful, especially since the second question is asking us to write it in factored form. Now when you look at this, it kind of looks like factored form because everything's in a bracket, but this subtraction in the middle is not in a bracket, and that means all the rest of it is not really helpful. So what we're going to do is we're going to write it in expanded form. So let's expand the first bracket. You get x squared plus 18x plus 81. Again, how am I doing that? First times first is x squared. First times last is 9x. Inside is 9x again, so they add up to 18. And then I have 9 times 9 to make 81. When I expand the other one, I get x squared minus 3x, but then plus 3x, and then minus 9. So it would look something like this. The next line would look something like this. X squared plus 18x plus 81. Okay. And then let's subtract. So we'll distribute the negative. Minus x squared, 0x, and 9. Okay. Now we got to be careful here. The subtraction it's a bracket, right? So like again, what I was doing yesterday where you put it underneath, it might be worth doing that here. So we'll take this, we'll put it underneath so that everything's kind of lined up, or sort of lined up. There we go. And now I can actually do the subtraction. X squared minus x squared is 0. 18x is minus 0x is 18x, and then 81 take away negative 9 is 90. So the area of the shaded region is going to be 18x plus 90, right? Is going to be the expression that we've come up with. Now to factor this, right, which is what the second thing we're supposed to do is, all we're going to do is we're just going to write this down, 18x plus 90, and then we're going to factor it. You can factor out an 18, and we get x plus 5. Now, what it's asking us down here is to sub in a number to check to see that they're the same. So let's go with 7 and go with the big one first. So this is just a little applet I built that sort of controls, you know, I can change the x and it makes the shape a bit different, right? So let's do what they said, area 7. So if you make the area 7, it's a bit finicky here. If you make the area 7, then the big one is 16 times 16, which is 256. The small one is 4 times 10, which is 40. The overall area is 216, right? So we'll just do the shaded area, shaded equals, quickly do this, x plus 9 squared minus u squared minus 9. Okay, so that's the shaded region, right? It's 216 here when we put in 7. And you can see if I put in 6 instead, the shaded region is 198. Anyway, let's leave it at 7 because that's what the question's asking us. So let's put 7. And I want to compare this to the thing we came up with. Now the thing we came up with was 18 times x, which in my GeoGebra thing is called q, plus, sorry, that's not what it was, x plus 5, sorry, okay, so x plus 5. Okay, so that would be that, which would be equal to, let's quickly do this, 18 times that number plus 5. And if we do it this way, sorry, remember to make a space here. If we do it this way, you can see that our expression, which is 18 times x plus 5, also gives you the answer, right? And it actually gives you the same answer every time, no matter what variable I try. Right? I can set x to anything I want, and the area is always the exact same. So what we've managed to do in this question is we've managed to make the area of this thing that was fairly complicated, right? Like 4 different terms multiplying and subtracting. We've turned it into something really simple. Take a number, add 5, then multiply your result by 18. Okay? Are the results the same? Yes, they are the same because the two expressions are equivalent. We used algebraic rules, right? We used algebraic rules to get from one to the other. So we have proven that they are the same. Okay, so for today, just to finish up, you need to practice today. There's an assignment that's open for you on the website you can do. You can do the textbook work, but you have to be able to do simple trinomials and complex trinomials. Okay, these skills are essential. So try them today. Bring me questions tomorrow or post the questions on the website, and make sure that this is a skill that you have down and that you're comfortable with. If you come across anything that's giving you trouble, put a star beside it, post it to the website, or make sure that you have it tomorrow and you're able to ask me.